So in this video we're going to look at how to actually combine polynomials with other polynomials. For example, if we add or subtract polynomials. This is basically combining like terms. Now you do want to write them in standard order, so always start with your biggest exponent. So if I look at all of them, my biggest exponent is my squares. Now I am adding, so I'm going to have 3x squared plus x squared. Remember, there's a 1 in front. So 3 plus 1 gives me 4x squared. When you're adding, you are not going to change your exponents. Then we have the x's. So 11x plus negative 5x. This is going to give me 6x. And then of course I've got 4 plus negative 13 to get negative 9. So adding and subtracting is just combining like terms. Now you do need to be careful on the subtraction though with your double negatives. For instance, a lot of people for this, you're going to start with the y cubed. A lot of people are going to put negative y cubed as their first term, which is wrong. The first expression doesn't have any y cubed, so 0 y cubed minus negative y cubed gives you positive y cubed. Here's the easiest way to avoid it. Go ahead and rewrite this by distributing the negative. So y plus 4y squared minus 3 minus 1 minus 2y squared plus 5y plus y cubed. If you distribute that negative, you're not going to have to worry about missing any double negatives and subtracting when you should be adding, or vice versa. So it's just easier for many people to distribute it first, and then it's just combining like terms. So again, my biggest exponent's a 3, so I start with the y cubed. There's nothing to combine it with, so I'll just write it down. Next is your squares. We've got 4y, underline the wrong line, 4y squared and negative 2y squared to get positive 2y squared. Then I combine my y's. So y plus 5y gives me 6y. And then of course I've got my numbers. So negative 3 minus 1 gives me negative 4. Alright, multiplying. When you're multiplying polynomials, you are going to FOIL. First, outside, inside, last. That's what it stands for when we do binomials, but it's the same process. Basically, you distribute each term, or you can use the box. So for instance, I'm going to use the FOIL method on this one and the box method on this one. So FOIL. First, I'm going to multiply y and y cubed, or y squared to get y cubed. And I'm going to multiply here. Actually, I'm going to write it over here. Okay. Multiply here to get 2y squared, or w squared. Where did I get y? Multiply here. W times 1 is just w. Then I distribute the negative 7 to get negative 7w squared minus 14w minus 7. And now I combine like terms. So standard form, you start with your biggest exponent, which is w cubed. There's nothing to combine it with, so I just bring it down. Then my squares. 2w squared minus 7w squared gives me negative 5w squared. Then the w's. W minus 14w gives me negative 13w. And then bring down the negative 7. And there's my solution. Now, box method is what I'm going to use on this one. It does the same thing, it's just a different way of organizing your data. So when you have more than one term like this that you're going to be multiplying, be aware that you can't do everything at once. You're going to have to take it in stages. Also be aware that this exponent means what I have is, rewrite that first part, but for this I have 2x plus 1 times 2x plus 1. It might be better for you to write it out like this so you can see it before beginning. Now I'm going to go ahead and distribute this, which gives me 2x squared plus 4x. I'm going to keep this in parentheses because I'm not done, because I still have to multiply these. Now the box method is basically you put your terms on the outside of the box and then multiply what's on the outside of the boxes. So 2x times 2x gives me 4x squared. Multiply here and I get 2x. 1 times 2x is 2x. 1 times 1 is 1. And this has an advantage of keeping your like terms kind of together because they're diagonal from one another. So this is going to be 4x squared plus 4x plus 1. Now the box method is also can also be used no matter how many terms you are multiplying together. So this one I have a 2 and 3. So I'm going to write it like this. I have 2x squared and 4x along one side, and then 4x squared, 4x, and 1 along the other side. And it's still the box, and you're still doing it the same way. So 4x squared times 2x squared gives me 8x to the 4th. Multiply here and I get 16x cubed. Multiply here to get 8x cubed. Multiply here to get 16x, x squared. Multiply here to get 2x squared, and multiply here to get 4x. And again, my like terms are diagonal from one another. So no other x to the 4th, I'm just going to rewrite that. 8x cubed plus 16x cubed gives me 24x cubed. 2x squared plus 16x squared is 18x squared. And then 4x, there's no other like term for that one, so you just bring it over. And there we have it. Now, just like the previous one, it doesn't really matter which order you go in. If you want to, but you can only multiply 2 at a time. So, same as before, I'm going to distribute on this one. So, negative 3a minus 15. And multiply these. Again, FOIL or box, it doesn't matter. You're going to get the same thing. Many students prefer the box method because it's easier for them to organize the data. Some people prefer FOIL because it takes up less room. Doesn't matter, it does the same thing. So, I'm going to do the box. Have a, negative 2, a, and 8. This gives me a squared minus 2a, and 8a, and then negative 16. So when I combine them, I get a squared plus 6a minus 16, and then multiply those together. So, oops. Write it out there. There we go. So, multiplying here. Excuse me, sorry about that. Alright, so multiply here, I get negative 3a cubed. Here I get negative 18a squared. Multiply here and I get positive 48a. Multiply everything by negative 15 to get negative 15a squared. Negative 90a and positive 240. So this is equal to negative 3a cubed Add my squares here to get negative 33a squared. Add my a's to get negative 42a, and then my 240 has no like term. So there we go. Alright, so we've done add, subtract, we've done multiply, divide, or multiply, now we're going to divide. Now, when you're dividing, you're going to have, for now we're only dividing by monomials. Now, when you do this, you're going to divide every term on top by the term on the bottom. And if it helps you, you can rewrite the expression using that concept. You don't have to, but if it helps you, do this. So 9 divided by 3 gives me 3. M cubed divided by m is m squared. I've got the subtraction between them. 24 divided by 3 is 8m. So this one divided evenly. There we go. Now I'm going to rewrite this one too, but the last one I'm not going to rewrite. So 30c to the 8th d cubed over 12c squared d minus 36c to the 6th d squared divided by 12c squared d, and plus 6c cubed d over 12c squared d. Now I can only do this because it's addition and subtraction between them. If it was multiply, you have to follow exponent rules. Multiply, then divide. But because these are multiple terms, I can write it out this way. So 30 divided by 12 does not go evenly. What I have to do is I have to reduce it. They're both divisible by 6, so when I divide them both by 6, I get 5 and 2, 5 halves. Alright, c to the 8th divided by c squared is c to the 6th. D cubed divided by d is d squared. Next term, 36 divided by 12 is 3. C to the 6th divided by c squared is c to the 4th. D squared divided by d is d. And last term, 6 divided by 12 reduces to 1/2. C and the d's cancel, so it's just that. Now, rewriting it like I did here is a bit, can take some time, and it does take up room, but you don't have to do it. You just have to remember to divide every term by that value. So, I'm not going to rewrite it on this last one. I'm going to take 30 divided by 3 to get 10. X cubed divided by x squared is x. Minus 12 divided by 3 is 4. X squared divided by x squared gives me 1, so I'm not going to have anything there. It's just going to be the negative 4. Plus 9x divided by 3x squared. Well, 9 divided by 3 is 3. X divided by x squared is x to the negative 1. But you can't have a negative exponent, so you have to rewrite it. Now, that exponent only goes with that x. Therefore, only that x gets moved, and only to the bottom of that term. Alright, so that's it for operations with polynomials.